Hello. In this episode, we'll discuss about time series forecasting, and we'll give an introduction and then show how to prepare the data. So first, let's take an example look of a time series data taken from the monthly retail sales. Here is the time series. Here is a blown up picture. So it's an advanced retail sales. You can download the data by clicking here, right? It's in millions of dollars. It's not seasonally adjusted. What it means is that typically the economists use a smoothened data, but the purpose here is to see actually the monthly variation. So we are not using not seasonally adjusted data. And this shows the whole United States aggregate sales in the service sector. So if you see how pattern here, oftentimes an interest would be observing here all the past, where would the next month's sales be? According to what we learned in cross-sectional data, probably a good reasonable starting point would be taking an average, and that's where our guess is. But in a time series data where the data are arranged in terms of the progression of times, can we do better is really the question of why we have a special name of this particular data, which is timestamp data. And there are reasons why we have some hope that we can do better than just cross-sectional analysis. And the reason is, first, oftentimes these time series exhibit a trend, an upward trend or downward trend, some kind of trend. So if there's an upward trend, then we would expect it to, well, be higher on average in our playing here. Also, many social events and economic events occur periodically because the events depend on the calendar year, like Christmas comes every time, the same time of the year and such, and maybe shopping relates to that also. Influences the number. So we have here cyclic patterns, which we call seasonality. And given those things, we can probably do better than just guessing the average of the past, that here's a season and it's December. So January will be probably lower than December is what we can guess, isn't it? So these kind of idea, how we embed it. There's a long literature in economics called time series analysis. And that uses mostly linear algebra to do a lot of wonderful things. But here our focus is deep learning. So I will just mention how deep learning adds to this literature. So here's the basic idea. So we have the data in cross-sectional analysis of supervised learning. What we did was that we have an X variable, and then we guess the Y variable given a correct Y variable, and then compare the errors and such. In time series forecasting, we use the past data, let's say here the past 4 quarters of the data, and try to predict the next quarter. To make it usable for neural network, we rearrange the data in a sense that we have the past 4 quarters that we are going to use for prediction, like here, and then have the target as the next quarter data. Then we can just roll it, shift it 1 period forward, and then write the 4 quarters, and then the next quarter in the target here. So we arrange the data here to make it usable. So, and then it becomes nothing other than the supervised learning, like what we did in a cross-sectional analysis. So we'll go over an example of how to arrange the data. Basically, I'll show the example data that I showed you how to read it in. And then I'm showing using a sequence of data, we'll show how to construct the time series data from here to this. Okay. So let's go to Google Drive. Okay. Okay. So of course, you should, if you haven't done it so, in Google Drive, you can always click New and File Upload, and then it will pop up this window and go somewhere where your file is and upload a file. That's what you can do. So first we'll import libraries. I think what we commonly use, NumPy and Panda Matplotlib will include. Also, we'll be using TensorFlow as for machine learning. When you set it up, the neural network can solve it. So let's just go ahead and use it. Okay, so now the libraries are imported. We of course have to, let's first take a look at an example of this Federal Reserve data, which is here. And I downloaded an Excel file. Actually, it was a zip file that I had to unpack, and then it will open up an Excel file, which is here. So this is the Excel file that we have it from the Federal Reserve, again, as a reminder. This one, if you download it, like a CSV data, then actually it does give directly a CSV file, so that's fine. Now we have to read it in. We'll be using Panda Read Csv, and we'll be reading it not in the data frame, but a particular thing called series, a Panda in a series. We'll have reading it in a Panda series, and then let's plot it, a matplotlib plot, py.plot. I'll label it monthly retail sales, and let's plot it. Okay, so here we have it, and you can see the cyclic pattern here, and this is kind of an example of time series data. But now let's see how to prepare the data. So first, let me name a data series data trend. It's an NumPy array of 1 to 20, this integer. I'm having a list, and then send it into, convert it into NumPy array, and then have it in a Panda DataFrame, data trend, and the column name, I'll name it trend. Okay, so if you click it here, this is the trend, and here you have it. Okay. I can also create, of course, a trend that have two columns, trend 1 and trend 2, for example, like here. Okay, so 1, I had it increasing, 1, I had it decreasing integers from 1 to 10. Okay. So the key thing, so we want to convert this series data. Let's first consider a single series here. We want to convert it from just a single line, single column into, let's say, 3 columns, 1, 2, 3, 2, 3, 4, 4, 5, 6, sort of like that. And for the target being the next value. So how do you do this? So here's a function that you are welcome to just copy and use it whenever a use arises. It's probably the same without any changes for your purpose as well. What you have to be aware is that when we have this 1, 2, 3, 2, 3, 4, what we call here is that this is the end step or time steps. So we have 3 time steps or end step, and then we have end columns, isn't it? The how many of the time series we have, examples we have. Here, what we do is that we create a new variable that from X, we create a new variable X time series and Y time series, YTS and XTS, which XTS looks like this. There's 3 columns and 17 rows. So how we do this? Well, we find in the location for each in the length from X minus, so 20 minus 3 steps. Let's say we use 3 steps, then 3, so 17. And we increase the integer in a for loop. And find the location in the X that was a column vector from 1 to 20 from this I, okay, from 0 to 0 plus n step 3. Okay, so 0, 1, 2 will be what it is. And get the values and put it in the XTS. So that will fill up the first row. Okay? And also for the Y, we don't want to do all on steps. We just want to get the next number, which is II plus n step, and get the value and put in W and append it in Y. Okay? And we keep appending, meaning that we adding rows and rows and rows for those, and then do it. And eventually we'll do it here. I think it's best to understand this code once you run it. So we have the df trend. The df trend was, if you remember, df trend was the column vector from 1 to 20. And then so that will be my x. And from that, we are going to create x, and y, which is the x will be looking like this, and y will be looking like this. So the get time series, call that. And then you have to give what is the single sequence, and then how many time steps you're going to use to predict the next period. If you click it, it looks like this. In fact, you can take a look at how XX looks like. See, 1, 2, 3, 2, 3, 4, 3, 4, 5, 5, 6, and so forth until 17, 18, 19. Okay, so and our YY looks like 4, 5, 6, blah, blah, blah. Okay, all right. Okay, so I don't need that. There's another function that you could sometimes use when X is not a single sequence, but sometimes we want to predict the future from multiple time series. Let's say you have the GDP sequence, you have the inflation sequence, and multiple of them, and that's why I created an example here. So here are 2 columns, 1 to 20 and 20 to 1, 2 columns. If we have 2 series of sequences and we want to predict the future, how do we prepare the data? Okay, so here is a very similar thing, except that it takes X and Y. The X have the covariance, and Y is eventually what I want to predict, a single time series what I want to predict. Okay, so it's very similar, except here I'm having the X that is, well, in terms of the line here, it does the same, but let's take a look at it. So here is the time series 2, and you have the df trend, which contains 2 columns, and the df trend of the trend. Well, you can apply this function to a single time series, but I think the most important thing is the df trend 2, the 2 column thing. And in the df trend 2, the trend 1 column, so the first column, is what we'll use as a target. And let's see. So, and it's x2. What you can see here is that X had 2 columns, and it will slice and put 3 of them for the first column and the second column in the first one to use. And what are we going to predict? YY2. For that, you'll predict a 4. So you can see that how to prepare the data for the time series. The next episode, we'll see how to use it for deep learning to predict the time series. Thank you. Thank you for watching video.